What's up, everybody? It's Dan from Sage Math Tutoring, and this is a review sheet for a test that a student of mine is about to have. And these are some of the problems that we weren't able to get to in the session, so I figured I would do them really quick, make a video out of it. All right, divide the polynomials. First of all, clearly we need placeholders here. This is a good candidate for synthetic division because the degree here is 1. This is linear, so this is a good candidate for synthetic division. So let's sort of think about what the placeholders would be, though. We would need an x cubed term, right? We would need an x term. So that's sort of the situation we're dealing with. Looking at synthetic division, we have a -4 that goes there. We have a 1, we have a 0, we have a -1, we have a 0, we have a -7. Drop that down. -4 times 1 is -4. When you add these, it becomes that. And then you have this. That's -60, I think. um, -60, and then positive 240, I guess. And then subtracting 233, pretty sure. Hopefully, I'm not wrong. But anyway, 1 degree down from x to the fourth, that's going to be x cubed. So that's 1x cubed minus 4x squared plus 15x minus 60. And then we have the remainder part, which is like 233 over the divisor. The divisor was x plus 4. Pretty sure that's it. Over here, that's more long division because the degree of the divisor is 2, which makes it not a good candidate for um, synthetic division. Do we need any placeholders? No. Do we need any placeholders here? No, we do not. So we have x to the fourth plus 3x cubed minus 4x squared plus 5x plus 3, all divided by x squared plus x plus 4. X squared times what goes into or turns into x to the fourth? Well, that would be another x squared. Put it above the other x squared. I end up with x squared plus x to the third plus 4x squared. Subtracting all this, which really means changing the sign, that would become 2x cubed minus 8x squared. Let's be careful, that becomes that. Let's drop this down. We end up with plus 5x. Then we perform the same process. X squared times what number gives you a 2x cubed? That would be a positive 2x. Multiplying the divisor by that would give us 2x cubed plus 2x squared plus 8x. Subtracting, which really means change the sign, we would end up with negative 10x squared minus 3x. Drop that down. Then we perform the same process. X squared times what number gives you a negative 10x squared? That would become negative 10. So obviously, negative 10x squared minus 10x minus 40. Change the sign across the board. That would become 7x plus 43, unless I'm missing something. So therefore, the final answer would be this, plus 7x plus 43 all over the divisor, which was this, right? And that would be the final answer. So that's number 8. Number 9. Find all of the zeros of the function. Support your solution algebraically. I guess that is their way of saying, feel free to use your graphing calculator, find out where this thing crosses the x-axis. Those x values would indeed be your zeros, but then your teacher wants you to sort of prove that, algebraically. So I'll just cut to the chase with the algebra component. Finding the zeros is nothing more than setting that equal to 0, like the f of x equal to 0, and then solving for x. So it's the case that we would have 0. Factoring out the GCF would be a 2x, so we would have x to the fourth minus 6x squared plus 5. Now, my student and I already kind of did uh, the red parentheses scenario. Hopefully, my student recognizes that it would be along the lines of x squared there, and then we would have minus 5 minus 6. Um, no, minus 5 minus 1. What am I talking about? Am I tripping? Minus 5 minus 1. That should definitely work. And setting that equal to 0, solving, setting that equal to 0, and then solving, and then setting that equal to 0, and then solving should do it. So x would be 0 here. X would end up being plus minus radical 5, and x over here would be plus minus radical 1, also known as plus minus 1. Okay, so that is that one. This one here, if we were to use algebra as opposed to a graphing calculator, factoring out well, first of all, setting it equal to 0, then factoring out the GCF, GCF would just be 2 in this case. So we'd have x to the third. Oh, wait, is it a friggin' GCF of 2? No, it's not. Friggin' the 7x. 7 screws everything up. Unfortunately, there's no nice GCF. Hmm. Yeah, okay. It's okay. So factoring by grouping, we have the blue bracket pair, we have the green bracket pair when it comes to the blue bracket pair, that would be a GCF of literally just x squared times 2x minus 7. And then we have the green bracket pair, that would be a negative 4 on the outside. And that would be a 2x minus 7 also. Okay. Now, the reality is the red parentheses match, which is a beautiful thing. So that means that you would indeed have this x squared minus 4, and then you'd have the 2x minus 7 right there. Okay. It's the case that the yellow parentheses can factor into difference between two squares shenanigans. And this would be kind of off to the side, and we would still have this. So the yellow parentheses turns into x plus 2, x minus 2. And then we would have factored this totally, uh, setting that equal to 0, and we will be solving, setting that equal to 0, and we will be solving, setting that equal to 0, and we will be solving. Obviously, x equals negative 2. Obviously, x equals 2. Obviously, x equals 7 over 2 in that case. So hopefully that makes sense. That's number 10. Finally, number 11. Um, so they're kind of giving you a hint that this is one of the factors. So that will be in the final answer. This is their way of saying use synthetic division. So we would be putting 4 in there. Do we need any placeholders? No, we do not. So we have 1, negative 6, 3, 30, negative 40. Drop that down. We have 4, we have negative 2, we have negative 8, we have negative 5, we have negative 20, we have 10, we have 40. And we have a 0. Now that should have happened. That's actually how we know we're on the right track. This, therefore, is x cubed minus 2x squared minus 5x plus 10. Is this a factoring by grouping? We would have the red bracket pair. We would have the green bracket pair. As far as the red bracket pair, we could factor out an x squared. That would give us an x minus 2. As far as the green bracket pair, we could factor out a negative 5. That would indeed give us an x minus 2. The two black parentheses match, which is a beautiful thing. That means that is going to be one of the things. And then we're going to have another that says x squared minus 5 in that one. Um, and let's not forget that ultimately that's still a factor, right? So when we consider the sort of ultimate factorization of this, we could say that this whole thing equals, right, equals this as a factor, because they told us it's a factor, times the thing that we just found, right? So that would be the ultimate factorization, but of course we want to be setting that equal to zero and solving, right? So it's the case that all of that factorization is set equal to zero, and then due to this, it's x equals 4, due to this, x equals plus minus radical 5, and due to this, x equals 2. Hopefully that makes sense. Okay, so that's that one. It's number 11. Okay, moving on. Um, More of the same, I guess. So, hmm. Okay, so they probably want us to use a graphing calculator for that. And if we did that, we would see this graph right here where we have some, real weird zero here, negative whatever. Same with that. But this is a nice one. And I think your teacher, my student's teacher, wants him to use synthetic division when it comes to that. Um, it's the case that therefore one of the zeros is 2. Now you do not have to do the opposite sign because that actually is the zero. Whatever is the actual zero goes in the box for the record. So we would have 1, negative 2, 7, negative 14, negative 18, and 36. Now this should give us a remainder of 0. So 2 times 1 is 2, 0. 0, 7, 14, 0, 0, negative 18. And then that's going to be negative 36. And then we would have a 0. So this would be x to the fourth plus 0x cubed plus 7x squared plus 0x minus 18. Um, and of course, that is just this. And then you could factor this in accordance with the way that I sort of did before. You have x squared, 2 and 9 probably are the ones we need. This is minus and this is plus. Yeah. So the full factorization would actually be another one that says x minus 2, because let's not forget, that we had already discovered that one of the zeros is 2. And since one of the zeros is 2, that means that this had to have been a factor. Now, that might be redundant for me to do that, but let's just be clear. That means that x is 2. This means that x is equal to plus minus radical 2. And this would mean that x is equal to plus minus 3i. Now, I'm going to let my student think about that on his own. Just remember, if you set that equal to 0 and then solve, it should become that. So maybe verify that yourself. All right, so that's that. Looking at this one. Um, well, I have a feeling it's not going to be factorable by grouping, but let's find out. So we have x squared, we have x squared minus 2. And yeah, sure enough, not factorable by grouping, which is code for your teacher wants you to use a calculator for that to kind of see what's going on. So if we were to graph it, it would look like this. So it turns out that the zeros here are really nice. You have a negative 1 and a 3. So once again, your teacher, my student's teacher wants to for us to sort of verify algebraically, which is code for throw one of those zeros into synthetic division. So we have 1, 0, negative 2, because it's a placeholder, right? So we have negative 16, negative 15. Drop that down. We have 1, so we should get a remainder of 0 here. That would be a 3, that would be a 3, that would be a 9, that would be a 7, that would be a 21. That would be a 5, and then that would be a positive 15. That would be a 0. That's exactly what we wanted. Um, we can then, I don't know, try this. X to the third plus 3x squared plus 7x plus 5. Is that factorable by grouping? It is not. So that's not factorable by grouping either. So I'm going to put that off to the side. What we can do now is we're going to hit this next row with the other 0, which happens to be -1. So we'll drop that down. So that's a -1, that's a 2, that's a -2, that's a 5, that's a -5, that's a 0. And then we have this scenario, which is x squared plus 2x plus 5. That is not factorable, but that is something you can use the quadratic equation for. So that's going to become this, p squared minus 4ac all over 2a. That would be negative something plus minus something squared minus 4 times something equal or all over 2 times something. The so-called b in this case is 2, the so-called a in this case is 1, and the so-called c in this case is 5. So we have -2 plus minus radical 4 minus 20, so it will be imaginary, and then we have 2 -2 plus minus -16, I think, right? Over that, -2 plus minus 4i. Hopefully my student agrees with that. That would turn into really just -1 plus minus 2i. And those are your other answers. Now, in the previous ones, I've been like factoring everything. Let's just say we know what the zeros are. One of the zeros is 3, the other zero is -1. And here are the other two zeros, -1 plus 2i. And then the last zero is -1 minus 2i. So that's how you do that one. All right, looking at these. Write a polynomial of least degree with the given zeros. Hopefully, my student is remembering that anytime you have a rational or irrational zero, that means the conjugate is also the case. So that would be a negative radical. So therefore, we could begin the process of constructing a polynomial. I guess it's not necessarily a function. We could construct a polynomial with 4 parentheses because there are 4 zeros. One of them would be x minus 0. The other one would be x minus -5, aka x plus 5. One would be this, and then the other would be x minus negative radical 6, aka this. This is clearly just an x, so we don't need to be weird about that. And then let's focus on these. That's clearly a minus b times a plus b, which hopefully we remember is a squared minus b squared. So that means that is going to be, we could say, the green shenanigans, right? The green turns into the following green. That would be something squared minus something squared, namely x radical 6. And of course, that is x squared minus 6, just a 6. This over here, might as well just distribute. Why not? X squared plus 5x, and we still have that here. Now, FOIL, we could FOIL that, right? So first would be x to the fourth, outer would be -6x squared, inner would be positive 5x to the third, last would be -30x. Putting it in standard form is something the teacher would appreciate. So I do believe this would be the answer. Okay, hopefully that works. Looking at the next one, it is the case that anytime you have an imaginary solution, you need to have the conjugate present as well as also one of the zeros. Well, they were kind enough to do that for us. So we are ready to go. Now, different teachers have different ways of going about this. I'm gonna just do 3 parentheses. I like my way because it's my way. So we have x minus the first imaginary zero and then x minus the second imaginary zero. So my student needs to remember, just be on your game with this. It is the case that you could indeed distribute the negative into both of the things. I'm going to do that right now. So we have x minus 2 plus 5i. We have x minus 2 minus 5i. Next thing you know, you can sort of rewrite these, only slap a parentheses around the first pair, which doesn't really change the value of anything. Hopefully that makes sense. But the reason we did that is because now we can very clearly see, hopefully, that what we are dealing with is an A plus B situation times an A minus B situation. And hopefully we're remembering that that just becomes A squared minus B squared. So the new situation is going to be something squared minus something squared, right? What is the first something? The first something is an x minus 2. What is the second thing? That's a 5i. So we then can, of course, FOIL this. That becomes x squared minus 4x plus 4. Let's be very meticulous. That will become negative minus something, right? Well, what is that something? It's going to be a 25i squared. We'll worry about that later. So we have x minus 1 times x squared minus 4x plus 4 minus 25 times what is I squared? Well, that's just negative 1, right? So I think you can all see that this would be minus a negative 25, right? I'm really going slow motion with this reasoning process, but hopefully you all appreciate it. So we have x plus 25, or the whole situation plus 25 there. Obviously, that will just be plus 29. And then I would use the box method, so that would be x squared minus 4x plus 29, and then we x negative 1 there. So x squared times x is x cubed, negative 4x times x is negative 4x squared, positive 29 times x is 29x. We have negative x squared, we have positive 4x, we have negative 29. Like terms are diagonal, so we have x cubed minus 5x squared plus, what is that, 33x minus 29, and that is the answer. Hopefully that makes sense. There was a lot going on there. Okay, so that was problem number 15. Okay, looking at the next page. Once again, it's the case that if the teacher wants to give you zeros, uh, that are not only irrational but also imaginary, then we need to remember that the conjugate is also one of the zeros. So therefore, I think my student watching understands these would be the factors, which, are a little crazy. Um, x minus 4 minus I to the radical times radical 6. So once again, distributing, we would have the x plus 3, but then literally just this and this. At that point, putting parentheses around that one and acknowledging that that would result in an A minus B times an A plus B. And what do you do in that case? You would acknowledge that that's A squared minus B squared. So this is going to be something squared minus something squared. What is your so-called A? Well, it's the x minus 4 part. What's your B? It's the I radical 6 part. So x plus 3, and we're going to kind of go in slow motion here. This would be FOIL. When we do FOIL, that would be x squared minus 8x plus 16. Now, we will be meticulous with the next part. So that is going to be I squared times 6 because it's almost like you can apply that exponent to both of the things, right? And then continuing to be very meticulous. What is I squared? Well, that's just -1. So that's really -1 times 6, is it not? Continuing to be meticulous. That is such that it will be minus a -6, right? And continuing to be meticulous, that is such that it would be plus 6, okay? And of course, x plus 3 times x squared minus 8x plus 22. Time for the box method. X squared, -8x, 22. X, 3. Box, thing, column. Okay, x cubed, -x squared, 22x, 3x squared, -24x, 66. Diagonal like terms? Yeah. X cubed minus 6x squared minus 2x plus 66. And that is the polynomial that would work when it comes to these zeros. Okay. So that's that. Um, Using Descartes' rule of signs to determine the number and types of possible zeros of the function. Well, we have real zeros as a possibility, and those could be subdivided into, uh, you know, positive and negative. And then we have another section called imaginary zeros. And then you will have the total zeros. So these are sort of the figures that we want to take into account as we proceed down the line. So I'm just kind of getting ahead of this right now. Um, I am going to copy this and put it over here. So let's use Descartes' rule of signs, though, to find out the positive real zeros. So positive real zeros, I'll call that the PRZ, has to do with how many sign changes you have. And we have one sign change only. So it's possible that we have one positive real zero when it comes to this. Now, negative real zeros really have to do with what happens when you plug in a negative x in for x. Okay, so let me just rewrite this with empty parentheses. Okay, I don't think I'm making any mistakes so far. And plugging in a negative x into that would give us the same thing over here. This would switch signs. This would be sort of the same as it was before. This would switch signs. And how many sign changes are there? It goes from positive to negative. So that's 1, 2, and 3. So negative real zeros are 3, but then you have to subtract 2 from that. So there's either 3 negative real zeros or 1 negative real zero. Now, we know that the total zeros must be 4, generally speaking, because the degree is 4. Now, if it's the case that we have, um, one positive real zero, well, then you would have to imagine that that could be paired with one negative real zero. And then in that case, you would have two imaginary zeros. Now that is feasible, okay? Because the amount of imaginary zeros needs to be even, okay? So that's a feasible situation, right? We know that it's possible to have one positive real zero, which we accounted for in this row. Now, if that was the case, you could indeed have one negative real zero because that was a possibility. And if that was the case, well, then you'd have two imaginary zeros. So now let's imagine another possibility. I don't know. What if we had three negative real zeros? Well, you might be tempted to be like, that could be coupled with one positive real zeros. Well, that's certainly a possibility, right? So that second row that we just created, that's also something that would produce a total of four zeros. So I'm liking that. These run through all the possibilities of how many real zeros you might have. Okay, so hopefully my student is watching understands that. So this is one possibility of what the zeros could be, and this is another possibility. Now, let's my student watching, please just look at this scenario and please recognize that there are no other possibilities. Okay, so pause the video if you have to, and just think about how there are no other possibilities for this situation. And given these possibilities when it comes to the positive real zeros and the negative real zeros. For example, you might be tempted to say, well, what if we had four imaginary zeros? Wouldn't that work? Well, that would imply zero negative real zeros and zero positive real zeros, but zero was not a possibility here. Okay. In this case, we would have, in the second possibility, we'd have zero imaginary zeros, and that's certainly possible. Okay, so hopefully that makes sense. I guess that's all we need to do. So for that, looking at this one now, find the increasing, decreasing intervals, local, max, and min. Okay, yes, so that's okay. Yeah, we're gonna break that down um, in a very organized fashion. So they want us to find this first. Okay, so that will be our first mission. Our second mission would be local max. Our next mission is going to be the min. Then our next mission is going to be the x-intercepts. All right, so I want to be very um, organized. Okay, so I'm breaking all of this down because to me, if I don't break it down like this, it's just overwhelming. I got to be honest. It's a little bit on the overwhelming side. So we are looking for the increasing intervals, then we want the decreasing, then we want the max, then we want the min, then we want the x-intercepts. Where's this increasing? Well, it's increasing over the red sections. Well, what is that? It seems like it goes from there to there, and then from there. So that's negative one, two, three, four. So it goes from -4 to 0, increasing, right? Union symbol, and then it goes from one, two, three. Then it goes from 3 to infinity. So those are the increasing. Now we want the decreasing. Well, that's all the blue section, is it not? So that goes from negative infinity to -4, union. from 0 to 3. Okay. Local max. Well, that's clearly this. Um, they did mention the word points, local max and min points, so I'm assuming the teacher wants XY coordinates. So we have 0, comma 3. Local min would be the yellow guys, and that is -4, comma, what is that? 1, 2, 3, 4, 5, 6. I guess that's -6. -4, comma, -6. But also, um, this one, 2, 3, and then it goes down 1 and 2. So that would be 3, comma, -2. Um, and then finally, the x-intercepts. I think we can get away, well, just in case, honestly, for my student watching, maybe just do a thing where you continue to give the exact XY coordinate points. We certainly have one, two, three. This will make these purple. This purple point right there is -6, comma 0. This purple point right here, -2, comma 0. This purple point right here, 2, comma 0. And this purple point right there is 1, 2, 3, 4, 4, comma 0. Now let's be very clear. These are points. These are points. This is a point. This is interval notation. And this is interval notation. Now, the reason I'm spelling that out is because we do not want to confuse these with points for my student watching. This is intervals, whereas these are literal XY coordinates for the points. Is that all we have to do? No. Okay. Oh, more. Huh, what's that? All right. To know if it's odd or even, find out what happens when you plug negative x in to for x, right? So if we were to plug negative x in, that would become -20x to the fifth minus x to 8x to the third, uh, plus 2x. But then you could factor out a -1. And what would you have on the inside? Well, after factoring out that -1, you would actually have the original function. So in other words, if you plug negative x in for x, and then you factor out a -1, you would end up with the original function on the inside of the brackets. That means that it's odd. Okay, so that's that. The rule in summary is that if you have this scenario, it's odd. Now, for the record, the rule says also that if you plug in a negative x and you end up just with the original guy without needing to factor out the -1, it's even. I have a feeling that might happen with the next one, but we don't know. So let's see. Plugging in, yeah, I can already tell this is not going to be even. So plugging in a negative x is going to change the sign here. That's going to change. Now, the presence of this constant is going to make it so it's not odd either. Let's go ahead and factor out a -1. And we would see that it would become negative x cubed plus 2x, but then it would become plus 9. So that does not match the original, okay? Because these are different. So therefore it's not odd, but it's also not even, right? Because after plugging in the negative x, it's not like it churned out the original function again, right? So this is neither, okay? Neither the yellow situation nor this red situation happened, so it's going to be neither. So that's how you do that. Hopefully that makes sense. And I'll talk to you all later.